First, we want to look at the difference between temperature and heat. Temperature is an average. It's the average kinetic energy of the molecules. Heat is really a sum, and heat is a measurement of the flow of energy due to temperature differences. So like, for example, if you place your hand on a rock or something, it's typically colder, and so you will feel heat flow from your body to the rock, and so that feels colder. Also for this, we have the term enthalpy. Enthalpy is heat energy, so we're measuring heat energy or energy flowing from one object to another. In doing this, we're going to be doing some conversions and conversions between joules, kilojoules, calories, and kilocalories. So it's important that you know these different conversions. First, there's 1,000 joules and kilojoules. There's 1,000 calories in a kilocalorie, and calories are what you see in our food. That gives us an idea of how much energy we can get from the food. Notice if you're ever in Europe, you'll notice that instead of calories, they have joules on the food instead of calories. Calorie is the same as 4.184 joules. That is just a simple conversion unit. And then a kilocalorie, which is right here, is 1 kilocalorie is 4.184 kilojoules. Joules are the metric or the SI unit, and calories are the old English unit. So let's do a few conversions with these. So today we're going to do 3 conversions and 3 problems. So let's first do the 3 conversions. Let's convert 76.52 calories to kilocalories. So we're going to start with the number 76.52 calories. And then we need to do a conversion factor. And we know a kilocalorie is bigger than a calorie. So we'll say a kilocalorie at the top, which is what we're trying to find, is equal to 1,000 calories. And I'm just going to write 10 to the third for 1,000. And when we do it that way, our calories will cancel. And basically, we're going to divide 76.52 by 1,000. And then this is going to give us 0.07652 kilocalories. So that's your answer for the first one. For the next one, we're going to convert kilojoules to joules. So we'll start with the number 7.824 kilojoules. And in doing that conversion, we want kilojoules to cancel, so we'll put that on the bottom. And then we'll put joules on the top. We know there's 1,000, or 10 to the third, joules in a kilojoule. When we do this, we see that the kilojoules will cancel, so we can cancel those out. And so the kilojoules are gone. And then that gives us our final answer. Basically, we're moving a decimal 3 places to the right. So we get 7, I'll just write up here, 7,000, that's a comma, 824 joules. So far we've converted within the English system, within the metric system. Let's do one more. And in this one, we're going to go from kilocalories to joules. So this will require 2 steps. So we'll start with 52.99 kilocalories. And we'll need to do 2 conversions. First conversion will be from kilocalories to calories. And we know a kilocalorie is larger. I'm going to put that on the bottom so it'll cancel. So a kilocalorie is 1,000 calories, and I'm going to write 10 to the third calories at the top. And then we've got one more conversion. We got rid of kilocalories. I'm going to change calories to joules. And from the numbers I looked at previously, I know there's 4.184 joules in a calorie. And so what's nice is now these units should cancel, and so we can cancel, actually want to do this instead. So we can cancel our kilocalories, we can cancel our calories, and our final units will be in joules. And the answer you should get for this is 6.04 joules. Okay? Enthalpy change, and that's delta H. The delta didn't transfer well when I put it to explain everything, so the box should be a delta. So enthalpy change, or delta H, we use this in calorimetry. Calorimetry is when we measure the heat flow. A calorimeter is an apparatus that measures the flow of heat. The calorimeter is insulated. That's why we use the insulated cups in the lab. And we use that to help measure temperature change. So the delta H that's gained is equal to the delta H that's lost. So, or the Q gained is equal to Q lost. And to do this, we use the formula Q equals MC delta T. Let's go over what each of these values mean. Q is going to be in joules. That will be our Q. Our mass, let's use a different pen color here, make it a little bit more prominent. Our mass will be in grams. And C is unit for specific heat. And the specific heat for water, which is the one we use most often, is 4.184 joules over gram degrees Celsius. And then temperature, which is right here, is degrees Celsius. So what's nice is when we do the problems, we see the grams will cancel with the grams in the specific heat, and same for the degrees Celsius. So enthalpy change, which is the delta H, is a heat released or absorbed when a physical or chemical change occurs. Specific heat, which is the C value we see here in our formula, is a quantity of heat required to raise the temperature of 1 gram of a substance 1 degree Celsius. And the formula that we're using, once again, is Q is equal to M times C times delta T. And remember, delta H is the same thing as saying Q. We're going to do 3 problems today. This is one of the first problems. 69.5 kilojoules of heat is applied to 110 gram block of metal. The temperature of the metal increases by 11.4. Calculate the specific heat of the metal. So for this, we use a formula Q is equal to M times C times delta T. We want to change kilojoules to joules because the specific heat of metal is usually reported in joules. So we'll change that to 69,500 joules, and that would be J right there, is equal to the mass of the metal, and that is 1,010 grams. And C is what we're trying to find. That's our unknown. And the delta T is 11.4. So basically we need to divide 69,500 by 1,010 and also by 11.4. When you do that, you get a specific heat that's equal to 6.04, and the units for that would be joules over gram